Okay, hi everybody. So give the definition of the integral. The integral of a function on n-dimensional space over some region. So in particular, this means that we have, well, this symbol means is a subset of, or you could also read it as is contained in. So A is contained in Rn. A is a subset of Rn. Or you could say A lives inside Rn. So that's what this symbol means. It's just easier to write this. And then when you see that symbol, you should immediately think of a picture. Of course, 2 dimensions is the easiest to draw. Here is the set A. It's a subset of, well, R2 in this case. And what we're going to do is we're going to break it into pieces. And so I'll just sort of draw breaking into pieces. And then on each of those pieces, we're going to pick a point somewhere. Just one point on each piece. And then what we're going to do is we're going to take the limit as the size of the pieces goes to 0. So then the pieces get smaller and smaller. We're going to need more and more pieces. So you can also think as we're going to take a limit as the number of pieces we use goes to infinity, or the size of the piece goes to 0. But I'll just keep it. This is a good picture because we can actually see what's going on. And so sort of in formulas, we would say that we're going to break A. Well, A is equal to some piece A1 union some piece A2 together with, that's this symbol, it's a union of A3, the third piece, and etc. And then on each of these pieces, we're going to choose a point, like x1 will be an element of the first piece, x2 will be a point on the second piece, x3 a point on the third, etc. So this if you wanted some math formulas in terms of set notation. Okay, but all right, this is good. This is the picture we have for an integral. Now let's give the actual definition. So first, informally we'll say that this integral of f, of the function f over the region A, is a weighted sum of values of f on A, but weighted by what? Well, weighted by volume. So if A has bigger volume, this number will be a bigger number. If f has larger values, this number will be a bigger number. So it's a combination of the volume of the set A and the values of the function f when we plug in the points on A. Okay, now more formally, we can write in formulas that this integral, this is just some symbol that we can write, it'll be equal to, well, a limit of these sums. Now what are the sums? They're the volumes of the pieces times the value of the function f at a point that's on this piece, or somewhere inside this piece. So there's the xi. You can see it in the picture over here. But this is not enough. We need to say what is the limit, and so then I'll add some words, and you have to add some words because we just don't have good enough symbols for this, where we take the limit as the size, or another word for size is the volume, the volumes of the pieces AI go to 0. Okay. So another way to do this, you could write lim as the maximum of the volume of AI goes to 0. So this is our limit. So I just sort of describe what the limit is doing, shorter than these words. And then you could write of this sum, the volumes of the piece is the weight that's multiplied by the value of the function. Okay. So this is the definition of the integral. Now I'll say something just briefly, is that if you want to know more about this, you can look up something called the Riemann integral on Wikipedia. You can also look up something called the Lebesgue integral. And the Lebesgue integral was invented later, and it's invented specifically because there are different ways to define the integral. And Riemann integrals work for like the basic sorts of continuous functions, but Lebesgue integral is needed specifically for the kind of functions you have to deal with in quantum mechanics, and also for probability, but more importantly in math and science, Fourier analysis, which also connects to quantum mechanics. In order to do these things correctly and get good results, you needed a better definition of integral. And so it's sort of silly, in your first class on multivariable calculus, you don't need to see sort of a watered down version of one of these definitions. You'll see these later. The point that you need to understand is the informal nature of these two definitions, that we are summing the values of f weighted by volume. And this is what we want to get at. And there are multiple definitions. So they give slightly different results. And this is the basic idea.